Okay, in this lesson we're going to talk about 3 by 3 matrices, their determinants, and inverses. So we're not going to do much with the inverses, but we're going to verify whether or not two 3 by 3 matrices are inverses. Okay, so let's start off by finding the determinant. So finding the determinant of a 3 by 3 matrix is kind of strange the way that you actually do it. So the first step of finding a determinant is you take these first two columns and you rewrite them over here. So -1, 2, 0, 3, -4, 1. Kind of strange, right? Weird way to start off, but that's what you do. Okay, then the next step is also a bit strange. You are going to multiply the diagonals. So with 2 by 2 we multiply diagonals. Let me do different. Oh no, I was supposed to do a different color, but it didn't take when I clicked it. There we go. Okay, these two and these three. So that's why you extend the two columns, so that you can see what the elements that you multiply by over here are. You could just kind of like hook around. So like this one would stay the same, then this one I would come through here, and then I'd kind of go around and multiply by this third one over here, and then this one I would come around and multiply by these other two. So you see how this third number is 0 here, and then the other two numbers are the 2. So you don't have to rewrite the columns. If you want, you can just kind of hook around. But I like rewriting the columns because it's easier for me to see. Okay, so let's go ahead and do this. I'm going to do the blue first. -1 times -4 times -1. -1, -4, and -1. If I multiply those together. So then I'm going to add that to the purple multiplied together. 3 times 6 times 0. And then I'm going to add that to the pink multiplied together. 5 times 2 times 1. That's a 2. Curses, it doesn't look like a 2 anymore. Times 2. Okay, so that's -1 times -4 times -1, and that gives us a -4, plus 3 times 6 times 0 is 0, and then plus 5 times 2 times 1 is 10. So all of this added together gives us 6. Okay, so going this direction, when you multiply them and add them together, you get 6. Now this isn't the determinant quite yet. The determinant, also you have to subtract off. So you do these three, you add them together, and then you go the other direction. Let me show you what I mean by that. You go this way, and you subtract those. So it's one direction, you add them all together, and then you go the other direction and you subtract. So I know this is starting to look kind of crazy, but let's go ahead and do it anyway. 5 times -4 times 0. So 5 times -4 times 0, and then you're going to subtract 1 times 6 times -1, 1 times 6 times -1, and then you're going to subtract -1 times 2 times 3. So you add all these up and get 6, and then you subtract each of these. The red, so I'm going to subtract the red. 5 times -4 times 0 is 0. And then I'm going to subtract the orange. Subtract 1 times 6 times -1 is -6. And then I'm going to subtract -1 times 2 times 3 is -6 also. So 6 minus 0 is 6 minus -6. This is the same thing as plus 6. So the same thing as 6 minus 0 plus 6 plus 6. So 6 minus 0 is 6. 6 plus 6 plus 6 is 18. So the determinant of this matrix is equal to 18. The determinant of that matrix. Let me erase this and walk back real quickly what we did. We multiplied this row. Let's copy the columns again. -1, 2, 0, the first two. 3, -4, 1. We multiplied these three rows together, and then we added them up, and then we subtracted each of these rows. So another way to do that would be, let me clear this off, -1, 2, 0. So a faster way of doing this, of writing it, is to do -1 times -4 times -1 is a -4, and then 3 times 6 times 0 is 0, and then 5 times 2 times 1 is 10. So you add those three up, and then you subtract the other three. 5 times -4 times 0 is 0, and you add them together also, going in the other direction. 1 times 6 times -1 is -6, and then you add that to -1 times 2 times 3 is -6. So if I distributed this negative, we would have the same thing that we had before, -0 plus 6 plus 6. So it is the same thing, but you can kind of treat the two directions as separate things. You add them up going this way, and then you add them up going this way, and then you subtract them from each other, and you get 6 minus -12, which is the same thing, 18. So that's another way to do that if you prefer it that way. Okay, so I'm going to do these two problems in the extra help video, or I guess 4 problems in the extra help video. And then let's come over here and look at this next type of problem. So this right here is the identity matrix for multiplication for a 3x3 matrix. You saw this in the last video. This is the identity for a 3x3 matrix. And we're going to use that to verify whether or not these two matrices are inverses of each other. So how do you verify inverses? You multiply them together and see what you get. So I'm going to multiply matrix A and matrix B together. Alright, let's see if I can do this in a way that makes sense. So I'm going to start off with row 1, and I'm going to multiply it times all 3 columns. So here's my product matrix. I'm going to use this full space. And row 1 is going to, I'll just put it in red. Here's row 1. And I'm going to start off by multiplying row 1 times column 1. So that's going to give me this element, row 1 times column 1. So row 1 times column 1 is 1 times 0, which is 0. Let me not use that color. There we go. Which is 0, plus 5 times 0.2, which is 1. And -1 times 0 is 0. So this first element is just 1. So that first element is 1. Now the second element, let's do it in green, is going to go here. And I'm going to do 1 times 0, which is 0, plus 5 times -0.2, which is -1, and -1 times -1, which is 1. And so I get 0. So that element is 0. And I'm going to keep doing this for each one. So I'm going to show you the color coordination. So this is going to be, oops, let's switch back to my highlighter. So this is going to be yellow. This element's going to be green. This one is going to be blue. And then the orange row. Okay, so row 2 is going to give us the same thing. Okay, when I multiply it times the columns, I'm going to end up getting, oh no, let me undo that. I'm going to end up getting yellow through here, green through here, and blue through here. And when I do the last row, I'll do that in purple. Then it's going to give me a purple row with each of these elements. So if you can see what I'm kind of doing here with the color coordinations, I'm going row by row and I'm multiplying this row times all 3 columns. And when I multiply the red row by the yellow column, I get this element. And when I multiply the orange row by the green column, I get that orange row by the green column. So they go together really well. That's just a reminder from matrix multiplication. And I don't have to multiply all of this out because I already know these are inverses. This is what I'll get. So I want you to go through the exercise of multiplying them all and see if this is in fact true. That's how you verify that they're inverses. I'm going to do this one on the extra help video. And then in class we're going to talk about how do you solve equations like this. And you would do it the same way as we've done before. So let's call this matrix A and this matrix B. So we have an equation AX equals B. A times X equals B. So if we multiply by A inverse on both sides, and remember the side matters, so I need to multiply by A inverse on the left side of B, then these two are going to cancel out, and I'll just be left with X equals A inverse times B. So that hasn't changed. We're still solving it the same way that we solved this when these were 2 by 2 matrices, when this was a 2 by 2 matrix. But now, how do you find A inverse? How do you find A inverse for a 3 by 3 matrix? You can do it by hand, but it's a lot of calculation. So what we're going to do is we're going to turn to software, and we're going to have either a calculator or a computer program do that. But we'll do that as an exercise in class. And I believe that's it for this video. Yeah, so we're going to do another problem of the same type. But remember, to verify inverses, you multiply the two matrices together and you should get the identity. If you get the identity, then these two are inverses. If one of these is wrong, so let's say this one was 1 or this was -1, then these two are not inverses of each other.